All right, hello everyone. Welcome back to the next probability lesson. This one's all about two-way tables. So just reading the definition here, a two-way table is a frequency table that displays data collected from one source that belong to two different categories. One category of data is represented by rows, the others are represented by columns. Now, boring definition aside, it kind of just looks like this here in example one, where you have two columns here. So ignoring all this stuff that's kind of shaded darker, just you have two columns. One of them is for dominant people, people that have their left hand dominant or their right hand dominant. And you also have two rows here for the gender, female and male. And you're just going to see if there's any difference basically between the numbers. So each entry in the table is called a joint frequency. So all of these are frequencies, right? Like the frequency of people having their dominant hand being their right hand and being male is 92. That's the frequency of that event occurring. The word joint right here, think of the word joined, right? So they're called joint frequencies because it's dominant hand being their right hand joined with the fact that they're male. So that's 92 right there. That's why it's called a joint frequency. It's the joining of a column and a row. Now, the sums of the various rows or columns are called marginal frequencies. Those are the things over here that are shaded slightly differently. So, like right here, the 115, that means the total women. So 11 and 104 add to be 115. So it's basically just summing the row. Same thing here. 116 is just the sum of this row right here. 24 and 92. That's the total men. Like right here, 35 is the total people who have left hand dominant because it's just 11 plus 24. And then right here, right hand dominant total is 196. And then this number all the way here at the bottom right is just the total of everyone. All men and women added up, 231. All left-handed, right-hand dominant people added up, 231. It's just how many people they studied in this survey or whatever regarding one's dominant hand and gender. So this question here asks, what are the joint frequencies? All of these, your normal numbers, those are your joint frequencies. And then it asks, what are your marginal frequencies? They're all of these. Marginal frequencies are always the sum of the joint frequencies. And then this one at the bottom right is just the sum of everything. Marginal frequencies. The word marginal comes from the fact that, well, just look at them. They're literally in the margins. When someone's in the margins, they're off to the side. These frequencies are in the margins. They're off to the side and at the bottom here, the marginal frequencies. So let's look at this next question. Complete the two-way table below. This is kind of like a little puzzle. If you've ever played Sudoku or something like that, you're trying to fill in like a bunch of squares and whatnot. It's kind of the same concept here, except this is a lot easier. So for instance, let's try and fill in the first thing we can. Can you fill in how many people passed and studied? No, it's not really enough information. However, you can see here that we know how many people were studied overall, 50 people, and we know 10 of them failed. So you could subtract right here. These two numbers have to add to 50, so 40 of them must have passed. Same thing over here. 38 of them studied. How many did not study? Has to add with 50, or has to add to be 50 with 38. So that would be 12. Because 38 plus 12, that's how many people total, has to add to be 50. 40 plus 10, that's how many people total, has to add to be 50. Now we can start filling in the rest of this. So of the people who passed, 6 of them did not study. Hopefully that's not you. Now, there are 40 total, so the number of people who studied and passed must be 34. Let's do the next one. Let's just cover this. So of the people who studied, 34 of them passed, and 4 of them failed because it has to add to 38. So, and then lastly here, there's a bunch of different ways you could do this one, but just look, 6 plus whatever this is has to be 12. So 6 right there. So 12 people didn't study. Oof. Imagine being those people. All right. Now let's move to the next question. So I'm going to assume that you've seen pie charts before. I'm going to go over them a little bit right now, but they're kind of pretty intuitive. I mean, I see them like all the time in real life. People love using pie charts. So create a two-way table using the information from the Venn diagram below. Sorry, did I say pie charts? I meant to say Venn diagram. I don't know why in my head I get them mixed up sometimes. Find and interpret the marginal frequencies. So let's start by filling out all that we know here. So we have plays an instrument, we have speaks a foreign language, and right in the middle, this little overlap here, there's 16 people. So it's a survey of 80 students, and 16 of them both play an instrument and speak a foreign language. So play an instrument, speaks a foreign language, 16. Also, survey of 80 students, the total is going to be 80, right? All the way down here at the bottom right. Now, let's keep filling all this out. The number of people who speak a foreign language but don't play an instrument is 30. So do not play an instrument, but they do speak a foreign language, 30. Same thing over here. The number of people who play an instrument but don't speak a foreign language is 25. And lastly, see this number 9 outside? That means the people both didn't speak a foreign language and don't play an instrument. They're not inside either of the two circles. So that's right here. They're the boring people like me. So now the rest of the information you just have to fill out yourself. So how many people don't speak a foreign language total? 16 plus 30 is 46. Now you could solve this next one of two ways. You could either add 25 and 9 to get this number, or you could just subtract 46 from 80 to get this number. But it's going to be 34. That's how many people do not speak a foreign language. And let's fill out the rest of this. This one's going to be 41, and this one's going to be 39. Now that's it all filled out, but it does say to find and interpret the marginal frequencies. We have already found them. That's all these numbers right here, all of the sums of everything. But it does want us to interpret them. What that means is just say really quickly, just kind of what I already said earlier in the video. So the 41 means 41 people play an instrument. Total. It's like, doesn't care if they speak a foreign language or not. It's just 41 people play an instrument. That number is not on here, but you can easily figure it out by just adding 1625. Now for the 39 here, you would say 39 don't play an instrument. And then let's see, the 46 here means 46 people speak a foreign language. 34 people don't speak a foreign language. And this last number right here is always really easy to interpret. It's literally just 80 students surveyed. And you're done. That's what it means to interpret the marginal frequencies. You just describe what they mean like really quickly. Now, on the second page here, we're going to start talking about something called relative frequencies. So we've been talking about normal frequencies so far, but relative frequencies are kind of like just turning those numbers, like in the last problem, you had 30 people that speak a foreign language. You change that into basically a probability instead, like a percentage. Like instead of saying 30 people speak a foreign language, you would say something like, oh, 0.3 of the, or 0.2 of everyone speaks a foreign language. So 20% of people, something like that. So all these numbers, they have a version for the relative frequency because it means it's relative to one another. So joint relative frequency, if we look at this first example right here, is still just the numbers inside like it was before. It's the rows and columns joined together. So those are the frequencies joined together, and they're called relative frequencies because it's like their probabilities. They're relative to one another. They all add with one another to be 1, right? Like all probabilities have to add to be 1. If there's a 20% chance of something happening, there's an 80% chance of it not happening, something like that. So let's go through each definition one by one. First, joint relative frequency is the ratio of a frequency that is not in the total row or the total column of the total number of values or observations in a two-way table. Honestly, I don't care for these definitions. It's easier to just kind of show you what it means in like an example right here. But I will mention here, conditional relative frequency is the ratio of a joint relative frequency to a marginal relative frequency. You'll see why that one's a bit special in a minute or two. And yeah, we'll get to that in a second. So first off, a satellite TV provider surveys customers in 3 cities. Survey asks whether they would recommend a TV provider to a friend or not. The results, given as joint relative frequencies below, are shown in the two-way table. Find and interpret the marginal relative frequencies. And then it asks one other thing. I'll get to that in a minute. So what makes this different than the two-way tables we were talking about before is instead of like giving actual numbers of people, like on the first page of this lesson, it would have just given you numbers. Like it would have said like 1,200 people are from Glendale and said yes, something like that. But instead, we're just saying the percentage of people total. So 0.29 is a probability that someone is from Glendale and said yes. So you know what? Let's find all of those marginal relative frequencies right now. So just like the last time, the marginal means that they're just in the margins. They're the sums. So I'm going to add an extra column over here. And let me just extend these down a bit. There again, I'll put total right there. So let's sum them all up. 0.29 plus 0.05 is 0.34. 0.27 plus 0.03 is 0.3. Same thing over here. These numbers are going to be 0.88 because it's these 3 numbers added up. And then this is going to be 0.12. And this one right here is 0.36. So those are all the marginal relative frequencies, except for, what is this last one? The total of everything. Like I said, these are all probabilities. What is 0.88 plus 0.12? It's just 1. What is 0.34 plus 0.3 plus 0.36? It's just 1. So all of these numbers inside, these 6 joint relative frequencies will all add to 1. All of these marginal relative frequencies right here in the row add to 1. All of these marginal relative frequencies right here add to 1. So each time, because these are all just probabilities, they all have to add to 1. You know, this is 29%, 27%, 32%, and so on. So first off, let's describe or let's interpret these marginal relative frequencies. So this 0.88 right here, what this means is 88% of people said yes. They responded yes to this survey. So as you can see here, the row is the yes row, and 0.88, 88% said yes. It doesn't care about where they're from, Glendale, Santa Monica, or Long Beach. All it cares about is the sum of those numbers. So 88% people said yes. And this one here is 12% said no. Now right here, for the sums of each of these columns, they don't care if they said yes or no. It's just, what's the percentage or what's the chance that someone was from Glendale? Well, 34% chance they are from Glendale. Right here, 0.3, so it's 30% chance that they're from Santa Monica. And then lastly, there is a 36% chance someone is from Long Beach. And lastly, the one right here, again, there's nothing really to interpret there. It's just all probabilities have to add to 1 since they're all just chances of something happening. All right, now let's do the second part of this question. What is the probability that a randomly selected customer who is located in Glendale will recommend the provider? So let's read each of these joint relative frequencies inside the two-way table. So focusing on specifically Glendale, 0.29, 29% of people overall in the survey are from Glendale and said yes. 5% of people are from Glendale and said no. So specifically, the question is asking the probability that someone said that will recommend the provider so that they said yes, given that they are from Glendale. So you've seen this given symbol before in the last video. So probability that they say yes, given that they're from Glendale. It's not just 0.29 or 0.05, because those are percentages of the total amount. So those like take into account all the people from Santa Monica and Long Beach. So the way you're going to do this is So you're just going to take 0.29. That's how many people said yes from Glendale. Well, that's the percentage of people overall from this thing, divided by how many people overall are from Glendale. So it's like 0.34 of the total population. So this definition, back from up here, conditional relative frequency is the ratio of a joint relative frequency to the marginal one. So 0.25 is a joint one. 0.34 is the marginal one right here. So you can find a conditional relative frequency using a row total or a column total of a two-way table. So this was my column total, 0.34 right here. So let's actually do this math. What is 0.29 divided by 0.34? Plug into your calculator. It's about 0.85. So the answer here is there's an 85% chance that someone from Glendale responded yes to this survey. Because looking at it right here, 0.29 is 85% of 0.34. So like from the last video, we saw that one equation where it was like probability of A and B equals probability of A times probability of B given A. Well, you can just rearrange that formula slightly, and it's probability of B given A equals, if you divide probability of A from both sides, probability of A and B over probability of A. That's where this right here kind of comes from. The 0.29 is the probability that they're from Glendale and they said yes. And then 0.34 right here is just the probability that they're from Glendale. That's it. So the probability that they said yes, given that they're from Glendale, is 0.29 divided by 0.34, which is about 0.85. So you also just got to think of these things logically. If I just look at these two numbers, 0.29 and 0.05, overall, you could clearly see that more people said yes from Glendale, right? A majority of those people said yes. In fact, it's going to be about 85% of them. You kind of have to look at these problems logically when you write your answer down. That's a really good way to check your answer a lot of the time. Because if you write an answer and you say like, oh, 5%, say something like that, it would be wrong because just looking at the numbers, it just doesn't quite make sense logically. Now let's go to the next question. Using the joint and marginal relative frequencies below, or from the two-way table below, create a two-way table that displays the joint and marginal relative frequencies. So right here, these are all normal joint and marginal frequencies. They're just the normal versions from the previous page. Let's change them all into relative versions. So these are all normal numbers. They all add to 231. We want all of them to be probabilities, and we want them all to add to be just 1 down here. So let's start setting up our two-way table. So it needs to have the same number of columns and rows and all that. So I'm going to draw it like this. Okay, so there are 3 rows there. It takes a little while sometimes. So let's start off. There's a chance that they're female, male, and right here is the total. And over here, I'm going to extend this up a bit. Let's say that's one column, that's another. So right here, left-hand dominant, right-hand dominant, and there's the total again. So let's start off right here. So 11 out of 231 people are both female and have their left-hand dominant. So the way you're going to set this, you're going to find this probability is just 11 out of the 231 people, which rounds to about 0.05. So 5% of people total are female and have their left hand being dominant. Now you're going to do the same thing for these others. 24 out of 231 people, 24 out of 231, that gives me a percentage of 0.1. So 10% of people are left-handed and male. And then the same thing for these other two. You're going to do 104 divided by 231. That gives you 0.45 right here. And then you're going to do 92 divided by 231. That gives you 0.4. You'll notice all of these joint frequencies, if you add them up, add up to 1. This number at the bottom right of a relative frequencies two-way table always is 1. Now, these other ones, you could calculate them the same way. You could do 35 divided by 231, find that probability there. far easier way, just add up these two joint relative frequencies right here. You're going to get 0.15. You're going to get 0.85 right here. Right here, you're going to get 0.5 and 0.5. And you're done with this problem. It doesn't ask you to interpret them at all, so there's nothing really to do past that. You've changed this thing into this over here. It's pretty hard to change this back into this, though, if you're not given the total number of people, because you don't know what it's a percentage of. You know that, for instance, 10% of people are left-handed and male, but if you don't know how many people total were surveyed here, you have no way of changing this table here back into this one. Because, 10% of 100 is 10, but what's 10% of like 1,000 people? That's 100. So it all just kind of depends on what your total is. Now, right here at the bottom, I've given you a kind of like easy chart to reference. So for instance, this just depicts relative frequencies. So I was kind of going sorry, let me repeat that. This here, this event A and event C, this joint relative frequency right here is the probability that A and C occur. Again, all these probabilities add up to 1 down here at the bottom right. So like probability that event A occurs is just this marginal frequency here. It's all of these two added up. Probability that event C occurs is just these two added up, and so on. I just wrote this here to kind of give you a reference as to like if you want to look back and see, wait, which one was the the intersection of these two events, so probability of A and C, those were the ones inside the chart itself. Those were the joint relative frequencies. The joined between the column and the row, for instance. So like this cell right here in the chart, in the table, is the probability that event B occurs and event D occurs. All that. All right, now there is one more page I'm going to go over. It's just one big problem using these joint relative frequencies. So using the two-way table below, answer the following questions. Here's a bunch of joint relative frequencies. They all add to 1. They are from different cities. They responded yes or no to the survey. Does it matter what the survey was about? No. It's just a bunch of math questions right now. So what is the probability that someone who took this survey was from Tokyo and responded no? So this is probability. They are from Tokyo and they said no. That's just going to be this number right here, 0.341. So they're from Tokyo and they said no, 0.3341 chance. So it's a 34% chance, 34.1, that they are from Tokyo and respond no. All right, what is the probability that someone's from London respond yes to this survey? So probability that they said yes. So is this probability they said yes and they're from London, or is this probability they said yes given that they're from London? Because the way they worded the question, that actually means given right here. So it's a conditional probability. The condition is that they're from London. So it's not going to be as simple as just giving a number from the two-way table. You're going to have to just calculate it ever so slightly. So let's just look. We're only looking specifically at London right here. So probability they said yes is this one right here, 0.136. That's the probability someone said yes and they're from London. So probability they said yes and they're from London divided by the probability that they are from just London in general. So probability of yes in London, that is 0.136. Probability that they're from London itself is 0.248. So that rounds to about 0.548. So it's about 54% chance, 54.8, that someone from London said yes to the survey. A bit of a cough. All right, what is the probability that someone responded no to the survey was from Washington, D.C.? So the probability that they're from Washington, D.C., given that they responded no. So of the people who responded no, so that's of the 0.644 amount of people, how many of those were from Washington, D.C.? That would be this number right here, the 0.191% of people. So that rounds to about 0.297. So about 29.7% of people that responded no were from Washington, D.C. Let's keep going. What's the probability that someone responded no to the survey just in general? So all they're asking for is the probability they said no. They don't care about where they're from at all. So that's just going to be 0.644. It's just this row added up. 0.644 people responded no to the survey. What is the probability that someone was from Tokyo, London, or Washington, D.C.? So probability Tokyo, or they're from London, or they're from Washington, D.C. Kind of a trick question here because they only surveyed these three places, right? What's the probability that they're from any of these three places? Well, it's 100% chance, right? Because it's literally everyone from the survey. So the probability here is just 1. It's 100%. All right, and then now we're actually given how many people respond to the survey. So if 3,499 respond to the survey, how many said yes? So the probability that someone said yes is, let's see, 0.356. All right, so that means 0.356% or 35% of people, so 35% of this total respond yes to the survey. So 3,499 times probability of yes. So 3,499 times 0.356 is about, I'm just rounding here, that's why I said about how many people? 1,246 people said yes. That's 35% of 3,499. Now, lastly, if 1,282 people from Tokyo responded to the survey, about how many said no? So 1,282 people multiplied by the probability that they said no, given that they're from Tokyo. So of the people who said no from Tokyo, we would just multiply that by 1,282 to find out how many of those people. So probably they said no given that they're from Tokyo. So 0.39%, so 39% of people total were from Tokyo. So that's 0.39 at the bottom here. And then how many of those said no? Well, that is going to be 0.341. Oh, and I do need to multiply that by 1,282 because that's we need to find this percentage here. So that is going to round to about, if you plug all this into your calculator at once, about 1,121 people. So of the 1,282 people from Tokyo that respond to the survey, most of them, all 1,121 of them said no. So only a pretty small portion of them actually said yes to the survey. So a lot of this unit here, about 12.3, all this two-way table stuff, is a lot of just logic here. You got to think about this stuff logically. So if it's all percentages, then, the percentage, you have to read the statement clearly and see oh, it's talking about from Washington, D.C., given that they said no or something like that. You have to make sure you're not saying Washington, D.C., and they said no. So there's a bit of differences there. Now, you have a bit more work for your, for these little extra practice problems. Have a bit of a cough still. So you have a bit more work for your extra practice problems. These first two are really easy. The next few, you have to just read the questions carefully and make sure you answer them. Read a pie chart, not pie chart. I don't know why you get that mixed up. Read a Venn diagram. And then, you have a bit more questions here. Just making sure you interpret a two-way table with relative frequencies and a two-way table with just normal frequencies, that kind of stuff. Now, I also just want to say I'm at my father's house right now and with my little siblings here. So in their room, I found this, Ethan's Pokemon book. I don't know why he's keeping some of these because they're not exactly very rare, right? Why do you need an energy card, for instance? I don't know. Seems like you could use this book for a lot more interesting cards to me. But that's just me. Oh well, see you in the next video.